All right, so we are back with a little bit more about hurricanes and kind of their formation in general. The one thing that you're probably the most familiar with is that center, that cloud-free center, which is the eye of the hurricane. Typically, an eye is between about 20 and around 40 miles wide, but the smaller the eye, the more compact the storm and the stronger the storm. The larger the eye, the storm can be a little disheveled and not be quite as strong. You can kind of think of it as like an ice skater. If you've ever watched ice skating during the Olympics or any other time. But an ice skater, when they spin and they have their arms out, they spin a lot slower than if they pull their arms in. They can go a lot faster. So the more compact the storm and the more compact the eye, the faster it can spin and really the stronger the storm in general. So for the most part, they're about 20 to 40 miles wide, but the smaller, the stronger the storm is going to be. Immediately surrounding that eye is a ring of thunderstorms, and that is called the eye wall. And those are going to be the strongest thunderstorms that you are going to see within that hurricane, right there in that eye wall. It's not very thick, but those are very, very powerful thunderstorms right there in the eye wall surrounding the eye. After that, you're going to be seeing rain bands. While it's going to be raining almost continuously throughout the hurricane, there are waves of stronger thunderstorms within it. So you'll get like heavy rain, strong thunderstorms, lighter rain, heavy rain, light rain, heavy rain, light rain. And it'll kind of go like that. The heavy rain or rain bands that kind of surround the storm. There'll be a rain band and then a rain band, another rain band. You can kind of think of it as like a ring. So those rain bands are slightly stronger thunderstorms, but not nearly as strong as those that we see within the eye wall. So with a hurricane, the hurricane is measured by the Saffir-Simpson scale. Just like the enhanced Fujita scale measures our strength of tornadoes. The difference is, of course, with tornadoes, we don't know the actual strength of that tornado until after it's passed and the National Weather Service goes out and surveys the scene. With a hurricane, we know exactly how strong it is as it's ongoing because of the hurricane hunters going out and dropping instrumentation down into it. We have buoys, we have ships, we have satellites all taking data. So we know how strong that storm is even well before it makes landfall. So a Category 1 is 74 to 95 miles an hour in terms of our wind speed. A Category 2 is winds in between 96 and 110 miles an hour. A Category 3, and this is when we start talking about major storms, is when we get Category 3 or better, is 111 to 130 miles an hour. Category 4 is 131 to 155 miles an hour, and a Category 5 is 155 miles an hour or greater. In the history of the United States, we've only been hit by about 4 or 5, at least that we know of, Category 5 storms, but of course, weather records only go back so far. Andrew was one. Andrew was actually reclassified as a 5 on the anniversary of the storm a couple of years ago. Camille was a 5. Katrina was only a Category 3 at landfall. So it doesn't have to be a Category 5 to produce just widespread destructive damage. It's kind of inversely related like that. It can, of course, be a Category 5 and create tremendous damage, but it doesn't have to be a Category 5. I think one of my dogs may be about to start barking here in just a second. Let's hope not. Dexter, no barking. Mom's doing a lecture. Thank you. Hopefully he'll be quiet. Maybe not. We'll see. Just a little bit longer though, so we'll see on that. But hurricanes have a lot. Dexter. Problems of doing this at home. So hurricanes bring with them a lot of destruction in a lot of ways. First and foremost is the storm surge. The storm surge is a very... Dexter. Shh. Doing a lecture. Thank you. Okay. I don't know what the threat is outside, but we'll see. So a storm surge is a very powerful just wave. If you think about it, that low pressure, it brings that water up. It brings it up. So it pulls it higher. So you're just think of it as a gigantic wave. That water all then piles up. The wind piles up all of that water and pushes it towards shore. Well, if you've ever been at the beach, you know, when you walk out from the beach and you walk out and it's shallow and you're kind of at your thigh, then it's you're at your waist, and then below, you go below the waves eventually, the water is going to get deeper. So the inverse is, as you're coming in, it's going to get shallower. All of that water has to go somewhere, and the only place is to go up on land. So that is the storm surge. Essentially, it is just a huge wall of water. One of the tallest ones was Katrina and also Camille at around 35 feet. So you think about that, that's a 3.5-story building, a big wall of water about 3.5 stories high. And just think about how powerful that is. All it takes is a couple of inches to actually move a car on land. So you're talking about a wave that's about 3.5 stories. That's why you see all of that destruction a lot of times that you see right there along the coast. So again, storm surge is one big wall of water as it moves inland. Some other threats that we see from hurricanes are actually tornadoes. The good news with tornadoes associated with hurricanes is generally they're very weak. They're EF0s, EF1s. And they almost always occur in the northeast quadrant of the storm. So what that means is, if you're looking at a map and you've got a hurricane that's moving inland like this, break it into quadrants. This is the northeast right here. The reason for that is those winds are coming inland right there. And because those winds are coming off the water and they hit land, they twist just enough that you get a little bit of spin in the atmosphere. And you can create some small tornadoes. But again, generally, they're EF0s, EF1s, not very powerful, while still powerful enough if you get hit by one. But they're not your EF4s, EF5s that you're going to be seeing during the spring or the winter with other storm systems. And then, of course, the last thing that you have to worry about with hurricanes is just the rainfall. Especially if a storm just sits over an area, it can create tremendous flooding problems like what we saw in Houston a couple of years ago. Actually, with Camille killed more people in the West Virginia mountains than it did on the Mississippi Gulf Coast. The reason for that is because it rained so much in the mountains and it created so many flash floods. It rained about 20 plus inches in the mountains of West Virginia. So it just created huge flash floods, and that created a lot of problems in a lot of towns and communities. So just the huge amounts of rainfall that we get with these systems, combined with the storm surge, combined with the winds, obviously, where you have winds that could reach about 155 miles an hour, combined with the tornado threat. So really you've got four main things that you're worried with when hurricanes come on shore. So we're going to talk very briefly in one more quick video, just a few pictures. I'm just going to kind of go over some of these pictures that you'll see in the PowerPoint in what those depict in just a second.